Hey everyone and welcome to WTF is Monadic Error Handling. In this video I'll be going over different programming languages and how they handle errors. The idea of this video is to show that error handling in JavaScript and exceptions in Java are sometimes quite inconvenient. There are better alternatives in newer programming languages which introduce monads, a very useful set of data structures in order to handle errors in a type-safe fashion. Let's start with JavaScript. In all of the three languages we'll be doing the same. We are going to try to read the contents of a file that does not exist. As a consequence, there will be an error or an exception that we have to deal with. So let's head over into the method, read the contents of a file using the Node API, and we're using the readFileSync method of the file system module in Node. Of course, the package.json will exist, so we are doing something different. So we are saying does not exist in order to trigger an error. The question is only what kind of error will we see? How will the application behave? In all other cases, we'll try to write the contents of the file to the console. If I now run this application, we'll see that the application will crash with a not found exception. This isn't surprising because we're trying to access a file that does not exist. However, the IDE does not show that this method, in our case readFileSync, can throw an error. And even hovering over it, the documentation shows no indication whatsoever that this operation may fail. Another thing to keep in mind is that different libraries behave differently. In case there is an error, some throw errors, some return null, some return undefined, and then the question is, what is the difference between the three of those? It's just a mess. So let's check out a different language, in our case, Java. Unlike JavaScript, Java is much more explicit when it comes to exceptions. There are so-called checked exceptions that are checked during compile time. If you access a method that is known to be able to throw an exception, you must either catch it yourself or continue throwing it. If you don't do so, the compiler will complain. Let's see this in action. Over here, we're going to read the contents of a file, import the missing classes, in our case paths and files. And now we already see the difference between Java and JavaScript. Trying to call read all bytes is not necessarily possible, it won't compile, because there is an unhandled exception. Not only is it documented down here in the documentation of this method, it is also annotated at the language level using throws IO exception. IO exception is one of those checked exceptions that we have to deal with. And as I've said, we have options to do so. Either we catch it or we continue throwing it. So if I get over here to read all bytes, hit Alt Enter, we can see that I can annotate main as a method that can throw, or I can surround this with try catch. In the case where we actually have an exception, we can try to write to the console that something has gone wrong. And in all other cases, we can print the contents of the file. Now, if we run this, we can see that we have this error as expected. Of course, in JavaScript, it would be definitely possible to use try catch as well in order to catch the error. However, unlike in Java, there is no indication that this actually is necessary. Therefore, Java error handling using exceptions is quite nice, especially if they are checked exceptions that are statically analyzable by the compiler. Now let's move on to Rust. Yet again, a new language and a new way to deal with errors and exceptions. In fact, Rust doesn't really have exceptions. It only has panics where the entire application just crashes in very exceptional circumstances. In all other cases, it uses special types to denote whether something has been successful or not. Those specific types and data structures are usually called monads. So in order to see them in action, let's do the same as we've seen previously in JavaScript and in Java. First, we're going to try to read a file. Read the contents of a file. And since the autocomplete here is much smarter than me, I will just ignore this expect block here and intentionally write some bad code that we are going to fix later. Trying to invoke the read-to-string method will already show that we are not getting a string as a result. We will get result of string. These special data types that convey semantics at the type level wrap certain values. For example, this result object, which is called contents right now, may contain the actual value of the file or the contents of the file or not, depending on whether the read was successful. In order to access the wrapped content, in our case the string, we can call unwrap, and then we have a string that we can technically print to the console. If I run this now, we will be greeted with a panic. The reason being is that this file does not exist. So let's try something else. Instead of just supplying the input.txt, which does not exist, we're going to print the code of the application itself. Let's try this again. And there we have it. We have the entire content of the source file. However, as you have seen, unwrap being called on a result that was not successful will cause a panic. Using those monads, we are forced to make a deliberate choice to introduce checks on whether the result was actually successful or not. So instead of using unwrap, we can use unwrap or and supply a default value, say default. So let's break this once again by saying, okay, let's try to access input.txt by running this again. And then we can see that our contents is default. What unwrap or does is the following. If the result was successful and there is a wrapped value, we are just unwrapping it and getting it back. In all other cases, so when the operation did not succeed, we just return something default. In addition to monads forcing us to make a deliberate choice with checks, we can also chain very conveniently different methods. For example, if I call the map method, just like on lists, in order to operate on those items, I can call something like to uppercase on the entire contents. If I run this once again, of course, I won't see any change because we still have the default value. This means that map is not being executed on the value of read to string because there is no value. However, if I go back to the source code here and say main.rs and run this once again, we can see what Rust would look like if it was made by SQL developers. Similar to the complex result type, there exists a much simpler monad called option, which we will be using now. Now imagine the following. You're writing code for a backend system. So you're just trying to read certain elements from a database, say users. So what I'm going to do first is declare a struct called user, and we say, well, users have names and ages, which is completely fine. Next up, I want to introduce a function called findUser by ID. So let's go ahead. And you can see that the autocomplete is already suggesting to use the option type here. Imagine writing this in Java or JavaScript. What would you do if you don't find a user with the specified ID? Would you throw an error, an exception? Would you return null? Or in the case of JavaScript, would you even return undefined? And what is the difference between null and undefined? And why would it be an exception? Sometimes it is completely valid that you are trying to access a user in the database that does not exist. Why is this an exception? In those cases, using option is really convenient. This is once again a semantic data type, one of those monads, that allows you to convey more information. You can return a value that indicates, well, you found some user, or you found no user at all. And as a consequence, similar to our file operations that we've seen previously, every time somebody calls findUser by ID, they are forced to check first whether they actually got a user or not. However, they do not have to write some wacky if-else conditions. They can just chain methods such as map or unwrap. So let's finish the implementation of this function. Say if the ID equals 1, then we can return some hard-coded user. Say it's John of age 30. And otherwise, we just return none. So let's call this function. So let user equals findUser by ID, say 1. And you can see the return type here is option of user. It is not user. We could try to forcefully unwrap. However, if we would supply an ID that doesn't exist, we would get a panic. So let's make it much more safer. So to keep it simple, let's just return a default user if the operation was not successful. So unwrap or, and we just return an unknown user of age 0. Next, we can easily print the age of the selected user and his name. In this example, we've got John, who's 30 years old. And if we try to change the ID to 2, and we can see that unknown is 0 years old. And just like previously, we can add further methods here, such as map. We can operate on the user that was actually found and say, well, let's take the age of the user and double it. And instead of returning a default user, let's return a default age. Since I'm possibly mapping a user to a number, his doubled age, or 0, this line doesn't make any more sense, right? So let's remove it and complete the line with something more sensible. Let's run this. And we see that the user age is 0 in the case we don't find a user. And in the case of John, he suddenly became 60 years old. So to summarize, Rust doesn't have the notion of errors or exceptions just like Java or JavaScript. It uses specific types called result and option to wrap possible values and to convey further information whether something was successful or not, or in the case of option, whether there is some value or none. Using really convenient methods such as map or unwrap, you can apply certain mutations on the object and chain different functions, and you can try to return a default value if no value was present to begin with. Let's go back to our examples in Java and JavaScript and see how monads can be used over there. So within Java, there already exists a optional type and no result type. So let's come up with a quick example, say public static optional string get optional. Let's just take this. And similar to our find user by ID method, if you now call the get optional method, you are supposed to deal with this optional safely before trying to access the underlying value. Let's go ahead and try to get the optional, make the string uppercase if it exists, or otherwise just return nope. So final var result is get optional. And just like we've seen in Rust, there is a map method in Java. We can call string to uppercase. And in all other cases, we could just return a default value, say default or nope, and then print it to the console. If we now run this, we get hello world if our optional does exist. Otherwise, we could say optional empty. So this is the fallback case. If we run this now, we get nope. So instead of having to deal with exceptions or null pointers, it is often much better to stick to optional to convey that something is completely allowed to fail or to return no result in this case, and to force the consumer of the function, in our case the main method, to deal with it in a sensible manner without making any assumptions. For the sake of completeness, I want to show you how you can use the result monad that you've seen in Rust within the scope of Java. Unfortunately, Java does not have the result type as part of the standard library. However, there is a library called Vaver, which includes certain utility monads that you can use, and one of them is called either. The name either is usually more common than result because it tells you that you either get a value or an exception or error or any kind of type that shows that something went wrong. So let's come up with a simple artificial example once again. So public static either, say string get either, that's not really useful. So let's say on the left we have some kind of exception and here new arithmetic exception, something like that. Where in this case it means that either you get an exception on the left side or you get the actual value, a string on the right side. In our case, this initial implementation returns an error. Do keep in mind I just use the exception due to laziness, but I'm not throwing it. So over in our main method, what I can do here is the following. I can call get either. And just like in Rust, I could try to unwrap this result by calling get or else and returning a default value instead. Let's print this to the console and see what happens. Since our monad here is just returning an error, we are going into the default case where we just get the default value. The alternative here would be to call ida.write with some values such as hello world. Running this again, we can see that we get the wrapped value instead of our default value. Just like in the case of the optional, we have a few helpful methods such as map, which allows us to mutate the inner values such as string to uppercase. And now we get hello world written by an SQL developer. Now let's finalize our tour by going back to JavaScript. So let's clean this up, get rid of everything that we did before, and let's come up with an example on how to use the monads in JavaScript. I personally like to use the FPTS library because JavaScript has no monads in the standard library. So I'm going ahead to import the option monad, FPTS/option. And I'm writing a simple function once again to return an optional to show you how to deal with it in JavaScript. So function get optional value. And o.sum is pretty much the same as o of value, or in terms of Rust, sum value. In our case, it's 1. When we now try to call this method, this value is an option that may contain a number, but it does not have to. So we have to explicitly deal with it once again. Unlike the other implementations in Java and Rust, the syntax is slightly different because we have to operate on this monad in a functional style. So please bear with me. What I'm going to do is just change the value by calling the pipe method. We plug in the initial value that we have. We now say we call the map method from the option type, just adding one, maybe multiplying by 2. And then eventually we want to get the final value. So what I'm going to do is I'm going to get the value that is inside, assuming there is one. Otherwise, we will just return a 0. And finally, we'll just write this to the console and run this. As we can see, with the default value of 1, we add 1, so we have 2, multiply it by 2, so we reach 4. In case we do not want to return anything here, we just can return oh none. And then we get our default value of 0 as described in here. So at the end of the day, I hope that you enjoyed the trip through different languages to see how errors and exceptions can be handled as well. I personally really like using those monads, bringing those errors and exceptions down to the type level and not requiring that you pray somebody documents possible errors. Additionally, this can make code much more type safe. Thanks for watching. I'll see you in the next video, and until then, take care.